Welcome to today's session. My name is Carlo Bobilas, and I'll be your moderator. I'm pleased to introduce today's speaker, technical marketing engineer Eric Rennie. But before I hand over Mike, I do have a few housekeeping items to cover about today's session. Today's session will be recorded and made available on demand. We'll make sure to provide those details at the end. We'd love to hear from you during today's presentation. So if you are on WebEx and have a question for our speaker, please feel free to send it through the WebEx question and answer panel, where our wonderful panelists are ready to respond. For those tuning into our live stream, we thank you very much for joining in as well. You can scan the QR code to join our Slido. So without any further ado, I'd like to kick things off by welcoming Eric. Eric, over to you.
Thank you, Carlo. Good morning, good afternoon, or good evening, depending where you are in the world and listening to this stream. Glad to have you on this day. Like I said, we're going to talk about using Secure Network Analytics with Endace and Splunk in this short session today. I'm going to cover a couple of slides, just get you into the mode, and then I'm actually going to go through a demo. And the great thing about this demo, you'll see coming up, Carlo's going to share a link with you that you can actually follow along with me. So you can follow along on the demo as I go with that, or look at the demo after the session if you want to do that. So no need to grab any screenshots of the demo as we do that, as you want to have full access. So let's get into it. So I'm going to cover a very brief overview of Endace and who they are and why we work really well with those. We have a better together kind of story. I'll explain the demo environment that I set up and what we're demonstrating here. And we're going to simulate what we call a data exfiltration attack that Secure Analytics is going to trigger on. And we're going to see how we can use Endace to look at those packets from Secure Analytics and how we can look at the same infringement or alert from Splunk as well. So you get to see how we can do that. So we get a demo of the attack from the perspective of SNA and then from the perspective of Splunk, but both working with Endace as the packet capture device. Okay, so very brief overview of Endace. Like I said, what we've got deployed in the lab actually here is a vProbe, as I call virtual probe. But Endace, you have physical probes, and they vary actually in sizes depending on how much data you want to store or packets you want to store, for example. But the main key concept here is that it's always on network recording, as they say. So you connect it to a span port, mirror port, or a connection like that, and it's constantly running and sniffing that traffic. So it's capturing the packets, it's storing those packets, and obviously storage length or duration is obviously depending on what size of probe you buy from Endace and things like that. So there's a lot of variables there that you can do. So they can store up to terabytes or petabytes depending on what you want to achieve. The concept of the Endace probe is not long-term storage of those packets, but enough storage for you to go back forensically and look at the packets associated with an alert. Also with the Endace probe, as it says here, it's good for recording weeks or months of traffic, depending on the flow. It's also I say not also, but one concept we have to remember is the Endace probe is not doing analysis of those packets. Secure Network Analytics and Splunk is doing analysis of those packets. So what I mean by that is that the probe is capturing those packets, storing them in an efficient way, giving you access to replay those packets, but is not analyzing the packets, if that makes sense. So it's not doing the packet inspection of those packets, it's just doing packet capture. And that's what Endace is really good at, packet capture. And they pride themselves on that functionality, which I agree with. That's their sweet spot. So I just wanted to highlight that. Like I said, the main use case is really, as Endace members say, they're the black box or flight recorder of the network. Exactly what I said. Just doing that packet capture, recording all the activity, not analyzing it, but giving you the ability for you to do that as well, as we'll see in the demo. So it's capturing that vital network information, providing forensic information for evidence capturing. If you think about certain potential situations where you need proof of particular attacks, they have that. They're providing, like I said, that recording for you. And delivering that incident response for us. And that's how we tied in with SNA and Splunk, is we're using them for that incident response to give us the before, during, after when we see that alert. Because it's always recording, we can always go back before we saw that event. We can see it during the event or the alarm that we see generated, and after a time frame of that, we can see that actual evidence. And like I said, There's no digging or routing around in packet captures to do that. You will see in the demo, we can actually cross-launch from an alarm straight into that particular incident within Endace and see those associated packets with that for further analysis. Okay.
This
So
meeting
again,
is being recorded.
we understand the depth and breadth of any potential threat. That's the whole purpose of Endace here. So typical use cases is, and this is not specific to Endace, but any kind of NDR solution or network detection response solution like Secure Network Analytics, it's looking for that lateral movement, looking for data exfiltration, anyone sending lots of data in or out of the network. And that's actually the use case that I use in this environment, as you'll see, is the exfiltration that's coming up. Looking for any command and control type traffic, looking for that 0-day threat. Because we got those packets, we can actually analyze those for that particular attack framework. Now, on this slide, just want to show you how Endace actually fits into the Cisco actual portfolio, if you think about it. It's just not working with Cisco Secure Analytics, which you see in the middle here. So you see that icon saying Cisco SNA. You can see the Endace is sending us flow logs, or can send us flow logs on the green line there to SNA. It can also send us Zeek logs. So if you want to capture those Zeek logs, we can process them as well or analyze those. But you can see Endace works also with our Cisco XDR solution, with Splunk as well, and with Cisco malware, Cisco secure access. So it's not just about SNA that it fits into. Obviously, this session, we're focusing on, in this slide here, Cisco SNA in the middle of the slide and with Splunk. And that's what I'm going to demonstrate coming up. Now, a couple of things to note. Like I said, in our lab environment, we installed a virtual probe, Endace probe. And that probe, as we'll see in the demo setup, doesn't have an inbuilt flow sensor. So what I mean by that, on this diagram, it's showing the Endace packet capture device sending flow logs to SNA. That is possible because on the Endace physical probes, you can actually install the SNA flow sensor appliance, a virtual appliance, actually on the Endace packet capture device itself. It has a capability to run that. And the beauty of it doing that is that you can basically send those flow logs directly into the SNA flow collector without needing to deploy a separate flow sensor on that. And there's other advantages. The fact that the flow sensor and the packet capture and its packet capture probe are seeing the same traffic, the network traffic. So it's great for correlation of alarms and alerts. And this kind of setup is used a lot in our security operations centers. There's actually one coming up in Amsterdam, in EMEA, shortly for Cisco Live. And this is what they actually deploy in those events to monitor those conferences and things like that. So it's really a good part of the puzzle here, because it gives us that packet capability to drill down into. So on the demo environment, I just briefly show you high level. Like I said, below there, there's a link. You see the walk or click through demo, as I call it there. If you cut and paste that into your browser, you'll be able to follow along with me. Or like I said, you can come back to this after this session if you want to. But I just wanted to show what the demo environment looks like before I start demonstrating it. So what we're going to simulate here, and I'll show you a bit more on the next slide here, is data exfiltration alert coming from the Linux server on the left. I've left the IP addresses on there so it makes sense here. But that's obviously from our lab environment. So just be aware of that. You won't be able to get to these devices, but anyway. So we've got a Linux server there, 10.90.15.227. And what that's doing is we're sending up a large file, basically a 5 gigabyte file, up to mega.nz or New Zealand. Mega is a cloud sharing site or organization, like Dropbox or things like that, where you can send files and things to. Now, within SNA, we have a detection. One of our new detections looks for any traffic going to mega.nz. There's basically a signature detection built for that, and it will alert or generate an alert in SNA to say that we've seen data exfiltration to that particular organization or site, and will generate an alarm and alert. So we simulate that in this demo environment, doing that upload. And what we have here on the diagram, you see I've shown the flow sensor and the Endace virtual probe. Like I said, if I had a physical Endace probe, the flow sensor would be actually inside the probe itself, which is kind of cool. Obviously, on the virtual, it doesn't have the, should we say, horsepower to do that. So they're separate here. So they're two separate virtual appliances, the flow sensor and the probe. But notice they're looking at the same basically port or switch there. I've drawn a very basic LAN switch there. They're looking at the packets that's coming. So see the conversation of the Linux server. They see it going out to that site. So both the flow sensor needs that information in order to generate the alert or the detection for us. And the NS probe is just doing the full packet capture and storage. It's not doing anything else other than that. Now, on the right-hand side of the diagram, you see I've got the SNA manager. That's where we'll see the detection trigger. And what we'll do is we'll use something in SNA called external lookup. It's a feature where where you can configure basically lookups or pivoting to other solutions outside of SNA. Now, with that external lookup, we actually have Endace probe special configuration. So when we look at the alarm or the alert from a flow search, if we right click on it, again, this will make sense when I show you the click-through demo, we will then look at the source IP, which is our Linux server, and the destination IP, which is the Mega New Zealand site. That will auto-populate in the external lookup, and we'll send that to the probe. It will log us into the probe, and the probe will automatically do a filter on those IPs for that particular time frame as well for us. And then we can do some cool stuff when we see those packets. We can actually download them locally as a PCAP, open up in Wireshark, or we can actually open up on Wireshark on the probe itself if we want to. So it gives you several options of what you can do there. In the second part of the demo, we're going to show you from the Splunk perspective. So Endace actually has a Splunk app that you can load into Splunk, and it does a similar thing to what we're doing with SNA Manager, where we'll see the alarm and alert in Splunk, and from there, we can then pivot again back into the probe and look at the packets as well for that particular event. So this is kind of the two things I'll show you. So I'll show you from SNA Manager, the pivoting, using something we call external lookup, and again, pivoting from Splunk to Endace Probe for the same incident, but using the Endace Splunk app, which you can download and install in your environment. So hopefully that makes sense. Now, just one slide on what we're actually doing here. Remember I said, we're actually going to trigger a detection in SNA that we call data exploitation to Mega. And here in the description, it basically says why we think this one's important. And like it says here, it says a device that's transferred data to an IP associated with Mega. So once we do that, it's going to trigger that. Why do we pick on this one? Well, often we see threat actors use Mega for exfiltration because of its anonymous registration. And actually, I anonymously registered as a fictitious name and on it. It doesn't check. It doesn't care who you are. And the fact that it likes like client side and end-to-end encryption as well. So it's a great site for our bad guys out there and bad girls that they can use to exfiltrate data once they've inside the network. And you can see here the MITRE tactics and techniques that it coincides with. It's using predominantly NetFlow in our network. You will see the flow sensor on the demo diagram that I showed you. It converts the packets basically into NetFlow or IPFix, as we call it, the standards-based flow, and sends it into our flow collector for processing. So it's a good network-based kind of detection that we can do. Okay, so I'm going to go into the attack itself. Now, you'll have access to these slides after the presentation, and I've actually gone on each step in the slides, the actual simulation here. So here I show me uploading the file to Mega, putting in the file, and you'll see in the next bunch of slides that I'm not going to go through at the moment because I'm going to show you the walkthrough demo. I show you how SNA generates the alarm and alert and how we actually go through that step by step. So you see the steps of detection there. So what I'll do to make it a bit more interesting is, like I said, I'll stop that, and we'll quickly jump onto the walkthrough demo here. So you can follow along, or like I said, you've got the link. You can look at it later on. Just a few words about the walkthrough, click-through demo. I've put in some what I call not speech bubbles, but obviously audited or scripted kind of comments on what we're looking at. If you actually want to switch that off, you can actually just Control P if you want to go through that. That's all that's saying now. But anyway, this is where we're going to start. We start at the main dashboard here. And you see every time we click next, it's going to give us a bit of information. We're going to look at the top alarming hosts. So within SNA here, you can scroll up and down on these click-through demos, which is kind of cool. The top alarming host on the left here, this is my Linux server. Remember the IP address, 10.90.15.227. Notice it's at the top of the list here, and it's got two SNA alarms here, PV, policy violation, and an AN for anomaly detection. So that would also show up here. If I clicked on the 4 here, this was a live demo, you would see that, and obviously an anomaly as well. So what we do here from investigation, we click on that host IP address, and we get what we call a host report. You see here. Under the host report, we will see various information. We'll see host groups, things like that. If I just close that, oh, let me go back, sorry. I'm trying to move that box out of the way. We'll see here on the right-hand side that we've got some SNA alarms here. We've got the policy violation, high total traffic. Now, from this perspective, we don't see it reporting at the moment the mega detection that I mentioned, because in this particular view, we're looking at the peer-to-peer customer security vendor triggers, which is associated with that mega exfiltration. We also see high total traffic. So the way the SNA shows it here for this host is slightly different. It's showing it as high total traffic event, security event, and it's showing peer-to-peer. And that's because if you remember, we're sending a 5 gigabit file externally outside of our organization. So it's exfiltrating that. It doesn't like that. So it's generated those alerts for us. Now, if we expand that, you can see the roughly 5 gigabit file there and the tolerance that we recorded within Secure Network Analytics. Now, the concept here is that if we click on the associated flows, so what we do here is, it doesn't actually show you too well here, there's 3 dots under actions. When I click on that, you get this pop-up menu here, which shows associated flows, top reports, external lookup, for example. If I click on the associated flows for the high total traffic security event, it's going to then show me a breakdown here of those flows. I can obviously come up here and edit this flow search if I want to. So if those of you have not used SNA before, what we've done down here, we've gone from that host level, we've gone and looked at the host and the host report, we looked at the security events that it's recording or highlighting us, and then we've gone down into one individual security event to look at actual flows. Now the flows to me is like your phone record. It's showing here the start time, duration. You see in the columns here what actual bytes have been sent, who to, and things like that. What I'm saying here is you can actually edit this search if you wanted to and change any of these fields or add additional filters if you want to. But what I'm trying to show here is actually this guy here is their 5 gig file. And you can see the application that we were pulling up and calling this peer-to-peer file. And you'll see the total bytes is actually 11 gigs. And the reason why it's 11 gigs is because I did an upload and download when I did this demo. And you see it's going off to an address in Canada. But you'll also notice here, and I'll just point this out here, there's a smaller communication going on here to Luxembourg. This mega site actually uses 2 ports. This is the control port, the 31 address to Canada, to Luxembourg, and it's a lot less. And notice it uses a secure control, but the actual data is transferring. It's actually using it on port 80, which is kind of interesting. So you'll see these 2 ports open. That's usually the same for any kind of cloud storage. You'll always have a control channel that's on a well-known port on a well-known IP address. The actual data channel will change, I found on that. But anyway, the concept is we can see the transfer here. We see this is the file that's gone up. And next, we want to drill in a bit further. And here I'm just going through the subject IP address. Now, for this particular transfer, I want to see the packets. So this is where Endace comes into play. Remember what I'm going to do here, I'm going to pivot. I'm going to click again on the 3 dots here under the actions column, and I get the menu. This time, I'm going to say, let's do an external lookup. I want to pivot now into Endace. So what you'll see on my walkthrough here is I'm going to pivot into that. And when I pivot into Endace, it automatically fills in the IP address here for that flow. If I go back one, just in case you missed that, you'll see here's the subject IP, it's 10.90.15.227, and you'll see the peer IP address, the 185.206. Okay, so again, like I said, when I click on the actions column and do the external lookup, it auto populates that information in the filter here, the conversation. It also puts in the time frame here. Now it's defaulted to 10 minutes, but remember on the slide I said you can see the before, during, and after. You can actually come here and change that time if you want to go back an hour or back 6 hours or however long you have the data for. And the same going forward, you click on the calendar icon here. So you can increase that time frame and get it to go and analyze and look at the packets. On the Endace view, so we're actually in Endace, I should have said actually. We pivoted directly into Endace. So you can see we're in the Endace virtual probe. When I look at the probe here, I'm looking at application transmissions here and conversations. Now, this is actually the conversation that we're seeing. Now, in my lab, for some reason, it tries to do a DNS resolution, and this is not the correct DNS resolution, by the way, but that is the 10.90.15.227 address. And we can see the data traveling to and from there. Now, there's several things I can do. Like I said, I can adjust the date time here if I wanted to go back further with the Endace here. But another cool thing is I can click on tools up here, and I can actually, this is where I can download this particular capture and analyze this, like I said, either on my laptop or desktop, and I can open up in Wireshark, or under the tools menu, I can say open it up within the probe itself. Now, I recommend downloading it because if you're in a production environment and running Endace and you try to open up a large packet capture on Endace itself, it will be a bit slower. So as a tip, download it locally, especially if it's a large capture, and analyze it on your laptop or desktop. So on the tools menu drop down, you'll have that option to download as PCAP. You'll see the icon up here. Like I said, this could take a while if you've selected a very large time frame and filter, so be patient with that. But once it's downloaded, you can open it up in Wireshark, and away we go. So that was showing SNA with the external lookup pivot. Now within Splunk itself, I've logged into Splunk and I've installed an app. There's something called the Endace Fusion Connector. If you look on Splunk base, you will see that. I've installed it in my Splunk instance here. And when I click on the Fusion connector, it looks very similar to a standard kind of Splunk search. The only difference is obviously you have the Endace icon in the top right and Endace search you see here. Now, very simply, when I'm using the app, I can just click on data summary. And when I click on the data summary, it's going to show me various inputs. And in this particular instance, it's going to show me the searches I've done here. Now, I kind of cheated here because this is the search I've used before. And I just load that into the search and populate that in the SPL query. So what that's going to do is pull back any findings. Remember what I said was in SNA, in the version of SNA that I showed you, it only showed the attack as a high total traffic and peer-to-peer from the flow records. It didn't show it as what we call a new finding for the mega, but we're sending this into the Splunk, and I can actually search by the HTTP event and find it because we're sending that mega detection finding into Splunk as well. So that's why you see the SPL here, I have finding info, and I just say, give me this source IP address. So this is my Linux server. And if I wanted to go through that, you can see the contents of the finding here. You could expand these if you had a live system here, and you can see that it will be like the mega detection and things like that. What's important here for the, should we say, cross launch is to click what I call under the eye here. You have this little chevron icon. Once you click that, it expands it up, and you come down to event actions. Remember, we're still in the Endace Fusion app. So in the Endace Fusion app, under actions, when you click on that, you will see an option to do Endace search. Now, if you try to do this in a normal Splunk search, you won't have this option, obviously, because it's not the Endace app. But if I do Endace search now, what it's going to do is, again, grab the source of destination IP address. it's going to put it into the search box here. So you see here, we've got IP address 1, 10.90.15.227, and we've got IP address 2, which is the 185. Remember, that's the Canadian address that the data is going to. It's populated a time frame from the alert that we sent into Splunk. And again, I could adjust those. Another pro tip that I have here is don't go straight to pivot to vision. Now, pivot to vision means pivot to the Endace probe itself to see the packets. Click on search first. See if there's any packets for it before you go down to the individual probe to look at it. What it'll do when you do the search, it will put in that criteria, come back and show you, yes, I've got some packets. It could come back and say you have 0 packets. Maybe you need to adjust the time frame. So that's what saying it's worth to do the quick search first to see if the probe, and you see the probe IP address is 15.202, has anything before I want to pivot to that probe. Now, you could have multiple probes in a large environment. Obviously, we only have one here, and that's why it says pivot to vision. Vision oversees multiple probes in your Endace environment. We only have one here, so when we pivot, we're going to pivot directly to that Endace probe 202, like we did from SNA. When I click on next, you see same screen, but now we're pivoting from the Endace app from Splunk directly into Endace. So you see it's populated the same filter, which of course it will, because it's the same attack that we saw before. Again, we can adjust the before time and after time here, or even just adjust here where it says 10 minutes, adjust the time frame to the last hour if you want to. But the concept is that once we put the filter in, we should see some data and we should see the conversations going on here. And just to add something to here, if you've got enterprise security loaded into Splunk, and we can still see the attack even in enterprise security. And the beauty is that if we go under mission control in enterprise security, we click on next, we will see it. Remember, SNA is sending this particular attack into Splunk. Splunk is when we're doing a what you call it, a conversion or transferring to what they call the CIM model within Splunk, certain alarms from SNA. One of those alarms we're converting is the high total traffic. And if you remember on the initial screen in SNA, we see this mega exfiltration show up as a high total traffic or peer-to-peer file sharing. Well, that high total traffic appears here in enterprise security. It's automatically put into the analyst queue here in enterprise security. We see we're sitting in it, and this is coming from SNA. We can add that to the analyst queue so they can add it to a finding and basically do an investigation here. So if they wanted to, they can come up here to start investigation based on that. So they see the high total traffic. They don't see the mega alert name itself. That still stays in SNA, but because we're forwarding the high total traffic, they will see that. And again, you can scroll down here. If you're familiar with enterprise security, you get to see the rules, what was observed, where it came from. SNA here, you can see the SNA tools there. And if you create any response or playbooks, you have the adaptive responses here. So just showing you here. Obviously, this is not saying nothing to do with Endace, but it's just showing that the alarms and alerts can also feed that into that analyst queue for us. That's what I was going to show you there. Very quick session today on the demo. I guess over to Carlo or the panelists, is there any questions or do I need to go back over anything on that session?
Doesn't look like there's any questions in the queue that haven't been answered. Again, if you have a question, feel free to go ahead and submit them using the WebEx question and answer panel, or you can go ahead and if you're on the live stream, scan that QR code to jump on the Slido portion. You can submit your questions there as well.
Okay.
Don't see anything. Let's see. Question did come into the chat. Looks like Hayden is new to learning this, and he asks, "What is the mega that we are talking about?" Be able to
So
elaborate on that?
yeah, so Mega is, like I said, is a cloud provider for file storage, cloud file storage. So Mega is the organization name. So if you actually Google up mega.nz, and I say .nz because they're based in New Zealand, hence the NZ, it's just like Dropbox. hopefully you've done Dropbox or any other cloud storage where you save files online. So it's an app you can sign up there for free. Like I said, the reason why the bad actors out there like it is because, like I said, you can sign anonymously. They don't check who you're signing, so you can create, let's call it fictitious accounts. So you can stage an account there, and once you've infiltrated a network, you can basically export the data that you want to steal out. So if I put that slide back up, so if you think about it here, where's the slide about Mega? So we just shorten it to Mega. Mega is actually the name of the organization. So think about Mega as Dropbox itself. So like I said here, the reason why threat actors like it is because of that capability to export data to it, not because, a lot of people are monitoring Dropboxes and things like that, but not a lot of people actually monitor Mega and block it. And I guess I shouldn't say this because it's been recording, but even Cisco are not dropping it at the moment. But if I try to send stuff to Dropbox, for example, I will not get through the corporate firewalls. So that's another advantage at the moment for the Mega site. So if you're working in your IT organizations there, you might want to check that access if people are allowed access to that. But I know from my lab environment at the moment, I can still access that. So there's a potential there. If I was a bad person, I wanted to send stuff out of my lab environment, I could do that. Not from the corporate environment, but from my lab environment. So that's another reason why a lot of people like this. I said they're anonymous registration. Like I said, I signed up with a fictitious name. They don't check. They don't particularly care about that because the way they make their money is on storage. If you get a free account, I think up to about 5 GB, just over that. So I was just exceeding the limit when I was testing this. Anything above that, they start to charge you. So that's another thing to think about on that. And if you remember on the demo setup, if I come back here, show a picture of what we were doing here, that Linux server is inside my lab environment. We're going out to their website. So this is effectively the mega.nz. If you like I said, Google them, they've got a website, you can sign up. We were just basically uploading that file, nothing sensitive in the file, just a bunch of data, 5 GB file there. And what we were trying to do is get the flow sensor here to see that transfer, see that large transfer to an external IP address. And it looks at that IP address, it sends that information or converts the packet information, converts that packet information into NetFlow on this Ethernet 0, sends it into the SNA flow collector. The flow collector then analyzes and processes it. And then this is where you then see within the SNA manager itself, it will detect that, or we will see several things. We will see what we call a detection called Mega in the alerts view. We will also see high total traffic because all of a sudden we see a large transfer of data going to a site we've never seen before within the manager. And we saw that CSE rule that I mentioned, custom security event rule. So there's a rule there saying I see a lot of what it classes peer-to-peer traffic. So effectively, this thing manager generated kind of 3 alerts for this. It generated the new detection findings, as we call it, for the mega detection, which is signature based, so it's looking for a specific signature going to that particular organization. It also generated high total traffic based on just flow data, the volume of flow data, and also a custom security event triggered, which it detected what they call peer-to-peer, basically lost information being shared to what it classes as a peer-to-peer sharing network. So that manager actually generated 3 alerts. In Splunk, we forward that high total traffic and we forward the mega detection to it. So in Splunk, I'm not showing you on the demo, but I had a simple dashboard which shows that mega detection, and it also shows the high total traffic. So part of the demo, what we used from SNA, remember we used the external looker feature that when we saw that high total traffic, we were then able to pivot to the individual packets, and I was actually able to download them as a PCAP and open up in Wireshark. Also, what I showed in that walkthrough demo, so when you're going through it again on your own, we show the Endace app. Remember, Endace has an app which is similar to it's basically what we do with external lookup. It allows you to pivot from the app again using the source as destination IP. So it's doing exactly the same thing as we're doing from the SNA manager, but it's using the app from Splunk. So you don't have to do it in 2 places, but I wanted to show you that it's possible to do that if you wanted to. from a Splunk perspective, if you're sitting as a SOC analyst in Splunk, you could do that. We could pivot back into the virtual probe and see the event that basically was generated by SNA. Hopefully that makes more sense on that.
Awesome. And yes, Caden confirms. Yeah,
Okay, great.
says, that makes sense. Moving on, we have Mutahar asking if for that scenario, do we use Cisco Umbrella?
No. So yeah, I mean, exactly. If we were in a proper corporate IT environment, we have, as you know, Cisco. We have Cisco Umbrella running. It would block me to do that kind of activity. Only in this lab environment, we have let's call it a slightly more open environment. We have a DMZ environment where we haven't got Umbrella protecting us on this environment. Otherwise, we wouldn't be able to test these and simulate the tests, if that makes sense. Hopefully that makes sense.
You. All right. Nazar asks, does Endace require the installation of an agent or sensor on the endpoint device?
No, that's a good question. It's not an endpoint agent. It comes in several flavors. You could have physical probes, so big physical appliances, and they range from, with various sizes. It all depends on the physical, how much storage you want it to have. So you can start off really small. You can go up to basically full racks of these probes or large devices, which can store petabytes. Now, petabytes sounds a lot, possibly not a lot, depending on your data flow. It might be a week's worth of packet capture or maximum, depending on how much packets you're sniffing. So it's probes that need to connect to a span or mirror port, which I'm trying to show on this diagram here. It's this thin line here, like an old Ethernet LAN connection. It's connecting physically to a switch and span port, and it's doing packet sniffing or packet capturing on that. So it's not an agent on the end devices. So don't think of it as like an EDR, endpoint detection response. It's not that kind of thing. It's basically looking on the wire. It's tapping that wire and seeing all the traffic. So it's capturing everything on that. You can, on the probe itself, you can be more specific. You can set up filters and say, I only want to look at this IP address range or this particular traffic. I only want to store X amount of traffic. You can do a lot of, should we say, customization in order to save space. You can even tell the probe to not save, for example, encrypted traffic, because you haven't got the key and you can't decrypt it. So why take up a lot of storage space with stuff you can't read, and just save the header information, for example. So it's kind of flexible on that. So think about the Endace probe, the physical probe, or even the virtual probe, as a device that does all the packet sniffing, but allows you to tailor exactly what you want to capture. In our lab environment, we just allow it to capture everything because we don't have a lot of traffic in our lab environment, and we didn't put any additional filters on that. But you can do that in order to save space and increase the duration of those packet captures that you save, if that makes sense. Now, I did say the one difference on the physical probes. You notice in my diagram, the V probe, that's a virtual probe. So that's an image you can store in VMware, for example. You can download that and get that running kind of quickly. I only have one probe here. You can have multiple probes. So that's where you might need to install the Vision. The Vision will then manage the multiple probes. But also, like I said, on the physical probe, which is kind of cool, the flow sensor, which I'll show you separate on this diagram here, that can actually be installed inside the probe itself, and it will be looking at the same traffic, the same span that I show in Ethernet 1 here. So that's kind of cool. And I like that approach because whatever the probe sees, the flow sensor would see. So that means SNA would see. If you do it like I've done it here separately, and that's because the V probe doesn't support, well, it doesn't have the capacity to install the flow sensor on it. You have the potential that this span port or flow sensor is seeing different traffic from the probe itself. So that could result in you, when you do a cross launch from SNA or from Splunk, you might not pull up any packets at all because your probe is looking at a different complete segment of the network that your flow sensor is, if that makes sense. So this flow sensor could see the traffic, generate an alarm. When you go look for the packets, the probe goes, no, I don't have any packets for that. I didn't see that. So that's one disadvantage, having a separate flow sensor from the probe itself, as I see. it's kind of cool that you can combine them in a physical one. And I'm hoping they'll give that functionality in the virtual probe at some point. So that's the difference there. So, but it still works. You just got to make sure if you have a separate flow sensor that it's looking at the same network traffic as a probe itself, if that makes sense.
Thank you. Yeah, and the question did come up about the differences between the NA virtual probe and SNA sensor. So I think you've gone through that. So
Okay.
thank you very much for that. All right. Let me take a look. Doesn't look like there's any other questions. So I think we can go ahead and start to wrap up the session. Is there anything else you'd like to say before we wrap up?
No, the only last comment is, like I said, on the slide here, you have the link. You can go through the demo at your own pace if you want to go through this again, just to remind you of what we're doing there. So yeah, feel free to do that. That's all. But yeah, thank you for listening, and hopefully that was informative and kind of interesting to see how we can use, like I said, the network forensics, the network data, the packet data, alongside with SNA. I said I've been working with SNA for a long while. We often get asked the question, can SNA do packet capturing? No, Secure Networks is not a packet capture device. It's not our expertise, but it is Endace, working with our third-party vendor Endace, and hopefully they will be on the Cisco global price list shortly. They're working to do that. So that really helps us, in providing solutions here and helping customers and other people out there that want packet capture alongside NDR as well. So watch the space. There's some interesting stuff happening here. But yeah, that's it. Thank you.
Awesome. Thank you very much, Eric, and to our panelists and the whole team for bringing your knowledge to the Cisco community. Again, if you have a question, I've placed a link to the live stream recording page. You'll find a link in there that'll direct you to the post-event discussion thread. So we do encourage you to ask your questions there, continue the conversation. Again, I will place that walkthrough click demo in that post-event discussion thread as a resource. So definitely do visit that, bookmark it. Again, your feedback is important, and at this time, you'll be directed to a survey. So we do encourage you to take the time to participate. So again, we thank everyone for joining us today, and we will see you next time. Have a great day.